So I've been in the industry for about 18 years now. Started off my career with not networking. I was actually a programmer, did a lot of C, C++, Java, .NET, but obviously programming was something that was way above my league, so it was something that I could not understand. And it's kind of funny that it's coming back to haunt me, because now I got to go back and learn all the programming skills that I left years back. So going back to when I did my programming, which I could not understand, so I moved on towards networking. In fact, Cisco was something that it kind of just came to me. So way back, 18 years back, I did my CCNA. I think it was CCNA 301 or 401 back then. It was a really long time back. I think it was in the year 2000, I guess. But I did my CCNA and passed that. And once I finished that, worked for a couple of years, did my CCNP route switch, and again worked for a couple of years, and then finally decided that I should do my CCIE. That's when I started studying for the CCIE route switch. Now, obviously, for me, CCIE route switch was the first track that I looked at. Studied for about a year and a half for understanding the advanced technologies and attempted my CCIE route switch. I passed the CCIE route switch in the first try, so it wasn't the first attempt. And once I finished that, it was suddenly that I realized that I have absolutely no friends, because, you know, CCIE takes a lot of efforts and time, and you suddenly left with no friends. So once I finished my CCIE route switch, I kind of decided that I should go for another track. Now, obviously, for me, the service provider track was the obvious choice, because there was no big difference between route switch and service provider. It was not a big difference back then. I mean, now, yes, but back then, it wasn't much of a difference. So I studied for CCIE, the service provider, for about, I think, 8 months. After attempting my route switch, I took about 8 months and started studying for the CCIE service provider. I passed that in, again, the first try. So now I had 2 of my CCIEs, which was in the first try. Once I finished that, again worked for about 2 years, and then I was kind of pushed towards security, because security became a big thing back then. Cisco had acquired PICS and everybody was talking about security. So did my CCIE security and studied that for about 18 months. It took me about 18 months to learn all the technologies as far as CCIE security was concerned. So finally booked my lab for CCIE security and passed that in the first try. So it was 3 CCIEs I got in the first try. So by now I had absolutely no scare or such about CCIE, because I've done that 3 times. So once I got my CCIE security, then I was pretty happy. 3 CCIEs, that's more than enough. I don't need to have any other CCIEs. So obviously what I did was work for a couple of years again, and then I had to go towards voice. Voice was completely new for me. It was completely new for me. So I had to actually study right from scratch, from CCNA voice to CCNP voice. I still remember back then when I asked my mentor the first question, when I made my first call, it was, why is this phone call working when I don't have routes in the routing table? And he was like, it doesn't work like that. So I still remember that. So once I got enough knowledge about the CCIE voice level, I kind of booked my lab for CCIE voice. Now, I was absolutely not nervous, because I've given the CCIE 3 times, right? Route switch, service provider, security. 90% of the people fail. 90% of the people fail because they do not have, they're basically nervous. That's 90% of the people. They fail because, not because they don't know anything, it's mainly because they're kind of nervous because like $1,600 for the CCIE, right? I mean, back then it was $1,250, then it became $1,400, and then moved on to, I think, $1,500, and then maybe $1,600. I kind of expect Cisco to again raise that again. So book my lab for voice. I kind of have the habit of always booking my lab in different locations. I don't know why. It's probably because I'm spending so much money anyway in my flights, in my hotel, and the CCIE exam itself, so might as well see the country. So what I did was book my lab, attempted the lab, and this time I was all over the place. I could not complete the lab in 8 hours. I was all over the place. When I went in, I was super confident because I've given CCIEs before, so not nervous at all, but I could not finish the lab. So obviously I failed the CCIE voice. Now the first most important thing that you must do, whether it's a CCNA or a CCNP or a CCIE, doesn't really matter. You must rebook your lab or your any certification exam that you're giving if you fail. You must rebook your lab in about 30 days or 45 days. Don't spend more than 45 days between attempts. The only reason being is that you've already spent so much time in studying for a CCIE track. You've spent months and months of work. And once you give a gap, let's say of 1 year, what happens? You have to go back and start right from scratch. So that's something you don't want. So I booked my lab the second attempt in 30 days. Because what Cisco does when you fail, it kind of gives you an approximate breakup of what sections you kind of lost points on. Not the exact questions, obviously, but just a basic breakup of you probably got like 40% in section 1, you got like 50% in section 2. You just get a general breakup. Now when you go for the lab, you yourself know which questions I kind of messed up. So if you book your lab in 30 days, you can basically focus on just those topics that probably you lost points on. So I booked my lab again in 30 days. This time I was a bit nervous because it was the first time I had failed a CCIE exam. So I was a bit nervous. Booked my lab, go for the lab, and I finished my lab in 6 hours. I had 2 hours spare. But, you know, sometimes you get overconfident, so I finished my lab in 6 hours, get up and walk out. Pretty confident, everything was working, so I should pass. Get my result. It was fail again. And I was like, this is not right. Everything was working. So I speak to my mentor, and obviously he was like, you know what, maybe you didn't meet the question requirements. Because it's not about best practices. CCIE is not about just best practices. It's not about what you can make it work. It's basically about making it work and meeting the question requirements. So you have to actually read the question really carefully. That do you meet the question requirements? So did I meet it? Maybe yes, maybe not. So, but obviously I failed. So obviously not. I did not meet the question requirements. Rebooked my lab in 30 days. And this time, I finished my lab in about 5 hours. So I had 3 hours left. But I did not finish my lab. I did not walk out. I actually sat back, went back to the first question, verified everything again, start to end, if everything is working, and left at the end when the proctor told me, hey, you need to get out now. That's when I moved out. And I get my result in about 8 hours. And it was pass. So voice took me 3 attempts to pass. It was the toughest one that I would say, which was for me. And then I was like, okay, 4 CCIEs, I'm done with CCIEs anymore. I don't need any CCIEs anymore. So I'm actually done. So moved on to other technologies, other vendors, did a bit of Juniper, did Checkpoint and Palo Alto, all of that. And then finally Cisco announced that voice track is going to expire. And you have a choice of giving the CCIE written exam for the collaboration track and sending them an email to migrate from voice to collaboration. I did my written, but did not send them an email because I didn't have the heart of migrating it. Because if I'm teaching collaboration or any track, I might as well go and take the test, just to know how much I know of the new technologies. So gave the written and did not even plan for the collaboration track. It just happened that on one of the days that it was, I think, a Monday. On Monday, I actually booked my lab for collaboration, and it was for Friday. So it was just like 4 or 5 days ahead. Absolutely no preparation. But I was pretty confident because I've been working on the voice technologies for quite some time. So I was like, it should be okay. So booked my lab on Monday for Friday, flew to all the way to San Jose, and attempt my lab for collaboration. It took me complete 8 hours to complete the lab. I had like 3 minutes of spare time left. Absolutely no time to verify any configs. Finish the lab, go back to my hotel, not expecting anything, and I get my result in 2 hours. In 2 hours, I was pretty shocked. I was like, okay, if it's in 2 hours, I'm sure it's fail. Now, usually, Cisco sends you 2 emails. The first one is your result has been uploaded, and the second one is congratulations that you've passed. I get 1 email, so I'm like, oh, I don't even want to look at it, So it was a Friday, so I don't look at it. And then on Monday, I was like Saturday, Sunday, I was just like with family and traveling. On Monday morning, I check my email and I see 1 more email which says congratulations. I'm like, So collaboration took me again 1 attempt to pass. So it was basically 4 CCIs in 1 attempt, and voice took me about 3 attempts.
Wow, that's nice.
So the most important thing here is that you must reattempt if you fail. I mean, it's absolutely okay to fail a lab. I know great people who have like so many CCIs who are pretty well known in the industry, and none of them have passed in 1 or 2 tries. It's absolutely okay if you fail. You just have to focus on the topics that you lost points on. So that's enough about me. Let's now kickstart this session with DMVPN. So something about DMVPN overview. If you look at DMVPN, it's basically a Cisco iOS software solution for building IPSec and GRE VPNs in an easy, dynamic, scalable manner. Now, if you look at traditional before DMVPN, what was the problem? Think about the problem area. We had the legacy crypto maps, which basically had to be applied to a physical interface. The problem was that I had to use complex access lists to define interesting traffic. There was no support for dynamic routing protocols. And the most important was it was full mesh. So I had to actually configure full mesh. So imagine if I had 100 branch offices. I had to configure a VPN full mesh between all 100 sites, which could be kind of crazy and non-scalable, which you would not want. I mean, obviously, if you're paid by the hour, if you're a consultant and paid by the hour, that's the perfect solution. Makes sense. But again, going back, that was a big problem. It's not scalable. Interesting traffic is done through access lists. It has to be a mirrored access list on both sides. So imagine the nightmare as your branch offices increase, as your networks increase, your access list increases, which kind of makes it non-scalable. So DMVPN was a multi-point technology which could scale really well and give you basically connectivity between all your branch offices without actually creating a VPN tunnel. It just builds that dynamically. That was the best part about DMVPN. So Cisco DMVPN allows branch offices or branch locations to communicate directly with each other over the public WAN or internet, such as using voice over IP between 2 branch offices, but doesn't require a permanent VPN connection between those sites. So it's like if a branch office wants to talk to another branch office, it builds that VPN at that point of time dynamically. You don't have to have a static VPN built between all of your branch offices. Obviously, DMVPN, as you know, it relies on two main proven technologies. We have the NHRP and we have MGRE, which is the multi-point GRE tunnel interface. Obviously, I'm going to talk about NHRP and MGRE a bit more in depth later on, but just a general overview that NHRP creates a distributed mapping database of all spoke tunnels to the real public IP address. And obviously, GRE was modified from being a point-to-point technology to being a multi-point so that you can have one GRE tunnel to all destinations. You don't have to have thousands of tunnels created. That was a big advantage of using DMVPN. If you look at the features and benefits of DMVPN, like I said before, it provides full mesh connectivity between simple configuration of hub and spoke. So I don't need to build an actual static full mesh connectivity. It builds the full mesh automatically. Supports dynamically addressed spokes. So what happens in a normal crypto map, the legacy, or a site-to-site, point-to-point GRE tunnel? You need everybody to have a static IP address, which means even your branch offices, they need to have a static IP address, right? Because you define tunnel destination in every tunnel. That's the biggest problem. With DMVPN, your spokes could have a dynamic IP address. It could be even behind a NAT address. It could be a dynamic NAT, which is happening. It doesn't really matter whether your spoke has a static IP, whether your spoke has a dynamic IP, it does not matter. Whether your spoke is behind a static NAT or he's behind a dynamic PAT, it doesn't really matter. It allows zero-touch configuration for addition of new spokes. So highly scalable. So if I have 100 branch offices, and let's say if I add 100 more, zero-touch configuration on the hub. I could just be highly scalable, saying allowing all of my spokes to communicate with the hub automatically without actually doing any configuration on the hub. Obviously, if you are doing IPSec along with that, you would probably want to do a few more things on the hub, but you could even make that scalable by having your ISACM policy or your transform sets or your peers as 0.0.0.0 makes it more scalable but less secure. So it all depends on your configuration. So features automatic IPSec triggering for building the IPSec tunnel. So if I do add IPSec, then automatically spoke to spoke IPSec tunnel gets built between them. I don't need to build that. It just builds that automatically. Supports IP unicast, IP multicast, and dynamic routing protocols. Here the most important thing is dynamic routing protocols, because now I don't need to create static routes, which was the problem in legacy crypto maps. I had to use static routes. There was no support for dynamic routing protocols. But in DMVPN, I could use dynamic routing protocols. I don't need access lists. I can just learn the interesting traffic from the spoke branch offices. Like I said before, the spoke routers could be behind a dynamic NAT, but the hub router needs to be behind a static NAT. The hub needs to have a static IP address. Why is that? The spoke can be dynamic, right? I don't care about his IP address, but the hub needs to be static. The reason is the spoke router will come and register with the hub. So he actually comes to the hub and registers. That's why your hub needs to have a static IP address. It can't change, right? But your spoke comes and registers. So from the hub's perspective, the spoke is going to come back and say that I am going to come back to you and register. So before I go ahead, just a quick thing. If you have a question, just kind of put it up on chat and try not going off mute. All right, so coming back to the spoke can be dynamic NAT, the hub needs to be static. You can use DMVPN with usable or with IPSec or without IPSec. So IPSec kind of becomes optional If you don't want to have IPSec, you don't need to have IPSec. But obviously, any kind of DMVPN implementation, I wouldn't think that you would want to have your data not being encrypted. So you would kind of want IPSec. It does support IPv 1. It does support IPv 2. I see a question which says, what is the comparison for SD-WAN? So obviously, I'm not going to go off track from DMVPN, but yes, you can send me an email, and I can definitely discuss that with you, because we have a kind of a limited time on 2 hours to do a lot of things on DMVPN. So yes, you can send me an email, and we can definitely discuss that. I see one more question is that, do we have a diagram for explaining this? Yes, we would be looking at a diagram much ahead. This is just a general overview of the basic features and benefits. All right, so going back to IPSec. So we could use IPSec, we could not use IPSec. Dynamic spoke-to-spoke tunnels get automatically built, like I said before, that you don't have to build a separate tunnel to the spoke. It just gets built dynamically. Improves network performance by reducing latency and jitter. Why is that? Like I said, DMVPN supports spoke-to-spoke dynamic tunnel, right? So I don't need to go to the hub. So that basically reduces your latency and jitter automatically. Imagine if I had to go always from spoke to spoke through the hub. Obviously, there would be some kind of latency or jitter. But if I do a spoke-to-spoke direct, then obviously it reduces the latency. Optimizes the head office, which is the hub side bandwidth utilization, when you do spoke-to-spoke communication directly using DMVPN Phase II or Phase III. So that's just the basic general features and benefits. All right, so moving ahead is the problem which was before DMVPN. So when we did not have DMVPN, like I said before, everybody had to build a full mesh tunnel. So we had to create one separate GRE interface for every spoke. So if I have 100 spokes, I require 100 tunnels to be created. Imagine the nightmare of thinking about subnetting for every tunnel interface, routing protocols for every tunnel interface. So obviously that's a nightmare. So you required one tunnel interface per spoke, full mesh. So if I have 100 spokes, I need 100 tunnels on each spoke. That's a lot of configuration. Obviously, tunnels had to be predefined. Like I said before DMVPN, your destination has to be defined. So I'm going to decline that. So I see somebody, Himan, can you stop doing that? You have to be connected to the audio bridge for you to be able to hear the sound. Yes, you have to be connected to the audio. Without that, you would not hear me. You would just see my video. All right. So going ahead, so we do require static tunnel destination. If before DMVPN, you have to have static tunnel destination. So it requires static addresses for all spokes. It does support dynamic routing protocols. The biggest problem is large hub configuration. One interface per spoke. So if you have 250 spokes, you require 250 interfaces, 250 tunnels. And let's say if there was 7 lines per spoke, you have to configure, if you have 250 spokes, you need to configure 1,750 lines. That's the biggest problem before DMVPN. Spoke-to-spoke traffic is only through the hub unless you do a full mesh, which is non-scalable. Addition of spokes does require changes on the hub. All right. Let's go ahead. If you look at this diagram here, this is before DMVPN. So I have kind of a hub here, and I have, let's say, 2 spokes. And before DMVPN, I had to build a separate tunnel between all of them. If you see here, I have a tunnel here, which is tunnel 1, between hub and this spoke 1. I have a separate tunnel between hub and again spoke 2, which is tunnel 2. And I have a separate tunnel between spoke 1 and spoke 2. I have to go and configure multiple tunnels for full mesh. So that's the biggest problem. So how does your traffic flow? Let's look at that. If you see here, this is how my traffic would flow. If you want spoke-to-spoke direct communication, you would need to build a separate tunnel between them. There's no other choice. If I don't build a tunnel between spoke 1 and spoke 2, then obviously spoke 1, if he wants to communicate with spoke 2, it has to transit the hub. It has to transit. There was no other option. So either I build a full mesh tunnel, which means thousands of tunnels on every router, or I go through the hub, which is again causing a lot of jitter and latency on the hub, which you don't want. That was your problem before DMVPN. Now, how does DMVPN solve that? If you see after DMVPN, one MGRE, which is a multi-point GRE interface on each spoke, which supports all destinations. It supports all destinations. Dynamic tunnel building for the spokes. So I don't have to define a tunnel destination. It's not static anymore. I don't care what IP address you have. You come and register with me, and I will build a destination, tunnel destination for you. So dynamic building of tunnel destination. So NHRP registration and dynamic routing protocols helps us do that. Smaller hub configuration that if you look at from DMVPN perspective earlier, if I had 250 spokes, I required 250 tunnels. Now I need one interface for each spoke. So if you have 250 spokes, all you need is one interface per spoke. If you have 15 lines, including NHRP configuration, you have only 15 lines to configure on your devices, rather than configuring 1,760 lines. No need to touch the hub for new spokes, so it supports zero-touch deployment. Spoke-to-spoke traffic could be through the hub, which is DMVPN Phase I. We will talk a bit in depth about that a bit later on. So spoke-to-spoke traffic is direct through the hub, or it could be direct. So you could have DMVPN Phase II or Phase III to make the traffic go directly between the spokes. So if you look at this diagram now, I could have DMVPN Phase I, but all traffic goes through the hub. If you notice, I have only one tunnel on each router, just one tunnel. And if I want to go from spoke 1 to spoke 2, I could go through the hub, which is DMVPN Phase I, or I could go directly spoke to spoke, dynamic building, which is DMVPN Phase II or III, which I could make my traffic or a dynamic tunnel being built between spoke 1 and spoke 2. I do not need to transit the hub anymore. That was after DMVPN. So now let's look at the basic components of DMVPN. What does DMVPN comprise of? So obviously it comprises of NHRP. So we have something called as NHRP registration. the spoke dynamically registers its mapping with the NHS server. So here I see two words. I see the word NHS and I see NHRP. I'm going to give you an example of DNS, okay? Just to make you understand how DMVPN works with this NHS and NHRP. Think about DNS. Let's say if I have to access cisco.com, what do? I go and open my browser, type cisco.com. What does your machine do? The machine first will always look at its local database, which is his etc host file, his local cache. It checks, do I know cisco.com? If I do know, I don't need to ask any DNS server, right? But if I don't know, what do? I go to my DNS server. Let's say if it was an internal DNS server, then that internal DNS server sends a request further ahead to the root DNS server. What does the DNS server do? He checks his database, right? He checks his database for the A record and then responds back saying, hey, cisco.com is, let's say, 1.1.1.1. He responds back to you. What did you do? You actually asked the DNS server, who is cisco.com? The DNS server looked at his database and responded back saying cisco.com is equal to 1.1.1.1. Right? What did the DNS server do? He resolved an FQDN to an IP address. Exactly the same thing happens in DMVPN with just one change. The difference is, rather than resolving an FQDN to an IP address, it's going to resolve a private IP address to a public IP address. When I use the word private, it means your overlay IP address, or it also means your tunnel IP address, or your private IP address. When I use the word public IP, it means your underlay IP address, which is your actual connection to ISP. So it basically resolves IP to IP, private to public. Who does that? The NHS. So think of the NHS like the DNS server. He's not actually a DNS server, but he's like a DNS server. The only difference is that he's resolving an IP to an IP, private IP address, overlay IP address, resolving to a public IP address, which is your underlay IP address. And that communication of you with the NHS is done using NHRP. So NHRP registration happens. We have spokes dynamically registering its mapping information. When I say mapping, every spoke comes and registers with the hub and tells the hub that this is my private IP address and this is my public IP address. So here is my tunnel IP, which is the overlay, and here is my underlay IP address, which is your actual public IP address. Then we have NHRP resolution and redirects. So supports building dynamic spoke-to-spoke tunnels. Control and IP multicast traffic always goes through hub. Now this is a very important point to understand DMVPN. Extremely important. There are two things here that you must understand. Two things. The first one is we have control plane, we have data plane. Control plane is completely different from data plane, right? Control plane is always going to be from the hub, no matter what, irrespective of your phase 1, phase 2, or phase 3. Your control plane is always going to be with the hub, which means all your spokes will always have, let's say, an EIGRP neighborship, assumingly you were using EIGRP as your overlay routing protocol. Your spoke routes will always establish a neighborship with the hub. Spoke and spoke will never establish EIGRP adjacency, even though they're in the same broadcast domain on the overlay. They would never establish control plane neighborship with each other. They only form neighborship with the hub, which means the updates or the control plane information, the updates will always come from the hub, irrespective of your DMVPN Phase I, Phase II, or Phase III, irrespective of that. Data plane depends on your DMVPN phase. If you're doing DMVPN Phase I, then your data plane traffic goes through the hub, always. If you're doing DMVPN 2 or 3, then your data plane traffic can go spoke-to-spoke direct. So your data plane does not follow the control plane. It depends on your DMVPN phase implementation. Okay? So DMVPN Phase I, control plane is always from hub. Data plane is also from the hub. DMVPN Phase II and 3, control plane is always from the hub, but data plane is spoke-to-spoke direct. So unicast data traffic direct reduce load on the hub routers. Then the next component is your MGRE, which is your multi-point GRE. So single interface, I don't have to have hundreds of tunnel, just one interface to go to every destination. So dynamic building of destination, which happens in DMVPN. Then obviously we have one more component here, which is routing protocol. So you can use, obviously it's mainly designed for EIGRP. It has a lot of advantages of using EIGRP, but you can use OSPF, you can use RIP. I mean, you can use BGP also, but I wouldn't think that you would ever want to use BGP. It's just going to be slow, but mainly designed for EIGRP. We'll talk about the advantages of using EIGRP as the overlay versus using OSPF and RIP. So mainly used for EIGRP. IPSec is optional. If you do want to add IPSec, you can. IPSec provides data security. It does support IPv1. It does support IPv2. So now that we know the components of DMVPN, let's look at the actual registration process. So before I explain this, let's look at this diagram carefully, all right? So this is prior to DMVPN. Before you build a DMVPN, before you even start with any kind of VPN, whether it's DMVPN or legacy crypto map site-to-site or GRE, before you build any kind of VPN, you must understand that you must have underlay connectivity. If you look at this one, this diagram, I have a link here which connects to an ISP. Similarly, Spoke 1 has a link that connects to an ISP, and Spoke 2 has a link that connects to an ISP. And I see an IP address here, which is 187.0.0.254. I see an IP address here, which is 167.1.1.1, and there's one IP here, which is 133.2.2.2. Now, what is that? This is your actual physical infrastructure, which actually goes to the internet, your WAN link, right? So your actual physical infrastructure must be in place before you build any kind of DMVPN, which means the hub should be able to reach the public IP address of the Spoke, or Spoke should be able to reach the public IP address of the hub. So obviously, if you're doing dynamic NAT, then Spoke can be having dynamic NAT, but hub needs to have a static IP address. But what is exactly this? LAN is not reachable. If you look at the color scheme that I've used, LAN is red, right? It's not going to be advertised in your underlay routing protocol. So this link here, the black line, would be called as your underlay interface. So gig 0 by 0 would be called as your underlay interface. 187 here, the IP address, is called as your underlay IP address, also known as public IP address, or also known as NBMA IP address. What's going to be your routing protocol? What do you think is going to be my routing protocol? Is it going to be OSPF? No. Your underlay is usually going to be BGP with an ISP, or it's going to be a static route. You're never going to run EIGRP or OSPF or RIP or ISIS with an ISP. You're either going to have a default route to the ISP, or you're going to run BGP with the ISP. So your underlay routing protocol is going to be BGP or static. In our case, I've actually used static routes to just point. I just have a default static route on each of the routers, which points to ISP. So either it's going to be static or it's going to be BGP as your underlay routing protocol. Do you think your LAN would ever be advertised in your underlay? No. That's behind the router. You only have access to that LAN after the VPN tunnel gets built. So this interface is called as underlay interface, underlay IP address, and underlay routing protocol is BGP or static. Now, if you look at this diagram here, this diagram shows you what an overlay interface is, what your overlay IP address is, and what's your overlay routing protocol. If you again see, I have put them in red. Why is that? Because my LAN is going to be advertised to all the branch offices, and the branch offices will advertise their interesting traffic, which is their LAN, in the tunnel. That's why the tunnel is red. So whatever is in red, that's my overlay interface. So I have one tunnel interface, which is called as the overlay interface. The IP address inside the tunnel, which is 172.16.1.254, that would be called as the overlay IP address. And the overlay routing protocol is going to be either EIGRP, OSPF, or RIP. Mainly, it's going to be EIGRP. So that's my overlay. So now that you know what is an underlay, what is an overlay, we can now look at the registration process. So if you look at this diagram here, I have put everything here. The left side again indicates what is an overlay, what is an underlay IP address and interfaces. Now, like I told you before, that every spoke will go and register with the hub. Now, how do they know that who is the hub? Obviously, the NHRP registration request is sent over the tunnel using the overlay. But obviously, the physical packet has to go from the underlay, right? I cannot have two routers communicating with each other using a tunnel when I don't have an underlay. There has to be an underlay because that's where my actual packet goes through. So how does the spoke know that he is the hub and this is where I should go and register? How does he know that? The reason he knows that because you must go to every spoke and define statically, you must define statically who the hub is. What is the private IP address or the overlay IP address of the hub? And what is the underlay IP address of the hub? You must statically define that. So if you look at this, again, diagram, you see something called as NHRP mapping. Think of the NHRP mapping like, again, DNS, your etc host file. So I'm actually going to your etc host file and making an entry there so that you don't have to ask a DNS server that who is the hub. So you have to actually go to every spoke and statically define that this is my hub. This is where I would go and register. Here is his private IP address, and here is his public IP address. You must statically define that. On the hub side, I don't need to define that. Why is that? Because every spoke will go and register with the hub. What does he register? He registers his private IP address and his public IP address. That happens automatically. As you can see here, that he has learned this dynamically. From where? From client registrations. So every client comes and registers with the hub. How does he know who the hub is? Because I've statically told him that he is the hub. Go and register there. And once the hub knows, once you have registered, the hub knows your private IP address and your underlay IP address, which is your public IP address. So every spoke does that. Okay? So that's your basic registration process. I'm going to show you when we actually lab it up, I'm going to show you the debugs of NHRP also, where we'll actually see the registration process. So now let's look at DMVPN Phase I. So in DMVPN Phase I, if you look at this diagram, I have an MGRE tunnel on the hub side. I have a point-to-point GRE on the spoke side. It could be a multi-point also. Let's say if I did plan to move to DMVPN 2 later on, then yes, I could make it multi-point on the spoke also. So, but based on this diagram, we see that I have a multi-point GRE on the hub and I have one tunnel interface on each spoke. Again, on the hub, I only have one tunnel interface, only one. Every router has only one tunnel interface. And every spoke goes and registers with the hub. What happens if now, from a control plane perspective, who would spoke 2 establish a neighborship with? Just the hub. Who will spoke 1 establish a neighborship? Just with the hub. Spoke 1 and spoke 2, even though on the overlay they're in the same broadcast domain. Spoke 1 is 172.16.1.1, spoke 2 is 172.16.1.2. Even though they're in the same broadcast domain, they would not be establishing control plane neighborship with each other. They only establish with the hub. So now it's the hub's responsibility to pass on the route of what he's learned from spoke 2 to spoke 1 and whatever he's learned from spoke 1 to spoke 2. So one thing that you must consider when you're doing that is you must disable split horizon if you are using EIGRP. If you're doing OSPF, you don't need to disable. There's no split horizon issue in OSPF. What makes it DMVPN 1 or 2 in OSPF? It's your network type. So let's say if you were using OSPF and you use the network type as point to multi-point, that's going to be DMVPN 1. If I use, let's say, broadcast or non-broadcast, then that would be DMVPN 2 automatically. What makes it DMVPN 1 or 2? Where in DMVPN 1, spoke-to-spoke communication must transit the hub. It will always transit the hub. Why does it not go directly? The reason it does not go directly is because hub, when he gives the control plane information to the spoke, he puts himself as the next hop. So spoke 1 gives his routes to the hub. Hub passes those routes to spoke 2, but he puts himself as the next hop, which means spoke 2 to reach this LAN, he would see next hop as what? The overlay of the hub, which is 172.16.1.254. He would see that as the next hop. So what am I going to do? See, look at the name, NHRP, Next Hop Resolution Protocol. Next hop plays an important role in DMVPN. So let's say if spoke 2 does a ping to this LAN, so he's going to do a routing lookup. Do I have routes to 10.1.0.0? Yes. What's my next hop? My next hop is the hub, which is 172.16.1.1. How do I get there? So he's going to check his local database first. Do I know who 172.16.1.254 is? Yes, he is 187.0.0.254. So now he encapsulates the packet with GRE, or if there's IPSec, then it's going to be IPSec on top of that, and he forwards the request to the hub. The hub then checks his database that the destination is going towards spoke 1. He re-encapsulates and forwards the packet here. So basically what's happening is, because the next hop is the hub, all your data plane traffic has to go through the hub. That's DMVPN Phase I. So if you see how my data is flowing here, it always goes from the hub, no matter what. There would be no data plane traffic flowing between spoke 1 and spoke 2. And the reason it does that, it's only because of the next hop, because the next hop is the hub. So in DMVPN 1, it's always going to be the hub as the next hop. EIGRP by default is DMVPN 1 because the default behavior of EIGRP in a multi-point environment is that it changes the next hop to himself. So I don't have to do anything. If I implement EIGRP as my overlay, automatically the hub is going to modify and put himself as the next hop when he advertises the routes. But OSPF is different. OSPF depends on the network type. If I keep the network type as point to multi-point, then OSPF puts himself as the next hop automatically. But if I choose broadcast as the network type, then OSPF does not modify the next hop. He keeps it unchanged. So this is DMVPN 1. All communications through the hub. Control plane is always from hub. Data plane also goes through the hub. Let's look at DMVPN Phase II. Now, if you look on the right side in this table here, you can see that the hub had learned both the spokes, private and public, dynamically through client registration. All the spokes were statically told who the hub is so that they can register with the hub. But look at this entry here, the second one. It says dynamic. So here what's going to happen is that in DMVPN Phase II, the hub is not going to modify the next hop. He is going to keep the next hop unchanged. So when spoke 1 gives his updates of his LAN to the hub, when hub passes that information to spoke 2, he keeps the next hop unchanged. Which means now when spoke 2 needs to reach this destination, when he does a routing lookup, what does he see as the next hop? He sees the next hop as 172.16.1.1. He sees that as the next hop. Now what am I going to do first? I'm going to check my local database, my NHRP mapping. Do I know who 172.16.1.1 is? No. Because earlier I didn't know this. This comes dynamically later on. But earlier I don't know that. The only entry that I had was a static mapping to the hub. I don't know who this 172.16.1.1 is. So what's going to happen? He is going to send an NHRP request. To who? The NHS server, which is like your DNS server. If I don't know who Cisco.com is in my local EDC host file, what do? I go to a DNS server. Same thing here. Spoke to checks his database. Do I know who this 172.16.1.1 is? No, I don't know who this is. So now he sends a request, an NHRP request, to asking who is 172.16.1.1. Does the hub respond back to him? No. What he does, he checks his database. Who is 172.16.1.1? It's 167.1.1.1. He forwards the request here. So this is an NHRP forward. He forwards that to spoke 1. Now spoke 1 gets the information that 172.16.1.2, whose IP address is 133.2.2.2, which is his underlay. He learns that dynamically. When he forwards that, he actually sends that request, because when spoke 2 actually send the request, he put his NBMA address also in the request, which the hub actually forwards, and now spoke 1 installs that in his NHRP map, and now he knows who spoke 2 is. What does he do? He now sends him a unicast, which is an NHRP reply. So he sends him an NHRP reply saying, I am 172.16.1.1 and my IP address is 167.1.1.1. How did spoke 1 learn about spoke 2? Through the hub, because the hub forwarded that request. How did spoke 2 learn about spoke 1? Through spoke 1 directly, because of unicast. Because when spoke 1 gets the information that he wants to communicate with me, he sends him an NHRP reply. Okay. So let's go to... So this is your basic NHRP table. And what we're going to look at is DMVPN Phase III. How is that different from Phase II? The whole concept of Phase II comes in is the hub does not modify the next hub. DMVPN Phase III is also spoke-to-spoke direct, like DMVPN 2. So why do we need that? There's a reason why DMVPN Phase III is there. The problem with DMVPN Phase II is that there is no support for summarization, which means if the hub ever summarizes the traffic, then spoke-to-spoke communication would never happen directly. It would never happen directly. Okay? So that's only if you summarize. Because now, and normally from a production perspective, you would want to summarize, right? I mean, I don't want like 1,000 routes of this spoke and 1,000 routes of this spokes being advertised, so many routes being advertised. So usually the hub would just send a default route down to the spokes, just one default route. So if I do summarize in DMVPN Phase II, the problem is that the spoke-to-spoke communication would not happen directly. It would become like DMVPN 1, that all data plane traffic goes through the hub. Okay, so that's the biggest problem with DMVPN Phase II, no spoke-to-spoke communication if you summarize. Now let's look at how DMVPN Phase III fixes that. So this was my earlier communication. All traffic goes through the hub, and then once it learns about the NHRP mappings, traffic goes directly between the spokes. It goes directly between spoke 1 and spoke 2. It does not need to transit the hub. Obviously, the first packet is going to go through the hub. It does not get dropped. So your data plane traffic, because spoke 2 does not know who spoke 1 is, so he sends NHRP request to the hub. Hub forwards it down, but at the same time, your data plane traffic goes through the hub. It doesn't get dropped. But once they know about each other, it switches over to spoke directly. Okay, so let's look at DMVPN Phase III. Phase III is a bit different. So here, as you can see, that we have something called as NHRP redirect. We have NHRP shortcut. And let's say if we did summarize on the hub, what's going to happen if I summarize on the hub? The spokes, no more, they don't have the specific routes to the branch office. They only have one default route, right? Since they just have a default route, what's going to be the next hop? The next hop is going to be the hub, which means my traffic will always go to the hub. So going to the hub and going down back. That's how my traffic is going to flow. So how does Phase III fix that? Now what happens is that in DMVPN Phase I, there was no NHRP request because my next hop was the hub. There was no NHRP request. In DMVPN Phase II, I did send an NHRP request to the hub because my next hop was the other spoke. So I did send an NHRP request to the hub. But in DMVPN Phase III, what's my next hop? I have a summarized route. What's my next hop? My next hop is the hub, which means will spoke 1 send an NHRP request asking for spoke 2? No. So he just forwards the packet here. When the hub gets the packet, he basically hairpins that and sends him an NHRP redirect. So an NHRP redirect is coming back from the hub saying that you may be using an unoptimized path. There is a better path available for you. Let me install that route for you. So that's why we need the NHRP shortcut command on the spoke so that the spoke can install that route for himself, which he learns from the hub. So the hub basically sends him an NHRP redirect message back saying that I'm going to install a route for you, but you need to send me a request first for the actual destination that you're trying to access. Earlier, he never sent him a request. He never sent NHRP requests, which says who is spoke to. He never sent that. He just forwarded the data packet here. Hub sends an NHRP redirect and tells him that there is a better path available. Send me an NHRP request for the actual destination you're trying to access. So now the spoke 1 sends an NHRP request for this destination. So now he sends an NHRP request. This guy forwards that NHRP request to spoke 2. What does that NHRP request contain? It contains the NBMA address of spoke 1 and the overlay IP address of spoke 1. It does contain that. Okay, it does contain that. It contains the overlay IP address. So again, I'm going to repeat that. This is a bit confusing. So you have to understand that. So he does not send any NHRP request. Once the hub receives the traffic without any NHRP request, he sees the destination is spoke 2, right? So that triggers the NHRP redirect message. So now he sends an NHRP redirect. So NHRP redirect saying, send me an NHRP request now for this destination. And now he sends him an NHRP request. Who is this destination? By putting his NBMA address and his overlay IP address in this request, which hub forwards here. Once the spoke gets to know about that, he sends him a reply. Now, once they know about each other, traffic directly flows between the spokes. So this is done by the NHRP redirect and the shortcut. You do need the shortcut command on the spoke side. The only reason being for him to be able to accept that route or the better path which is available, for him to accept that, which the hub is sending him an NHRP redirect, for him to accept that, he needs the shortcut command. Okay, so all spoke-to-spoke communication happens directly without transiting the hub. I see a question which says that in DMVPN Phase II and III, ISP must assure direct access between the spokes NBMA address, otherwise it won't work. I mean, yes, in a way, but let's say if you had maybe dynamic PAT happening, it doesn't really matter because the spoke comes and registers with the hub. So yes, if you do want spoke-to-spoke communication, then yes, you must have, the ISP must allow the NBM address to be reachable, which is normally the public IP address. I see another question which says, is NHRP communication asymmetric? Yes, to a point. I mean, it's not that the hub responds back to you. The spoke sends the request to hub, hub forwards, and spoke 2 responds back to spoke 1. We would see all of that in action when we actually do DMVPN implementation. All right, so this was your DMVPN Phase III. Let's see how the traffic is flowing. So initial traffic goes through the hub. In the meanwhile, at the back end, hub sends a redirect. The spokes now sends an NHRP request to the hub for the actual destination, which contains his NBMA address and his overlay IP address. And then spoke 2 responds back to spoke 1. But the same process in the reverse way also happens. He would also send him an NHRP request for the actual destination. and he would forward here, and then spoke 1 would also ask spoke 2. So here I see that there's one more question which I see. Doesn't the NHRP redirect contain the overlay IP address of the destination spoke saying to use the IP address as the next hop? Yes, it does. So it does contain the next hop, or the destination is going to be the actual destination, overlay destination that he's trying to access. I'm going to show you that in the debugs when we actually hit the router and actually configure DMVPN, and we're going to do a debug and see how the traffic is flowing. All right, so that's my traffic flowing directly between spoke to spoke once they have learned about each other. So now let's in fact look at DMVPN in action. So what I'm going to do is I'm going to pull another diagram, which is at the back. Here you go. So look at this diagram now. This is going to be our actual implementation. So in this diagram, we can see that the hub has an underlay IP address. Again, I think there's probably a mistake in this slide here. It's gig 0 by 0. It's not gig 0 by 0. It's probably gig 1.1. So my underlay IP address is gig 1.1, which is everywhere. That's my underlay IP address, my underlay interface. And then my underlay IP address is 187.0.0.254 for the hub, 167.1.1.1 for spoke 1, and 133.2.2.2 for spoke 2. Okay? The LAN interface, which we want to protect, or we want traffic flow between all of the LANs, that's 10.0.0.0 on hub, 10.1.0.0 on this spoke, and then we have 10.2.0.0 on spoke 2. So that's going to be my setup. All right? We're going to use tunnel 0 as the overlay interface. And the IP address is going to be 172.16.1.254 on the hub for the overlay, and then 172.16.1.1 for the overlay on spoke 1, and 172.16.1.2 as the overlay on spoke 2. Again, I see a question, any specific reason for using sub-interfaces? There's no special reason as such. It's just that I had less interfaces on some routers, so I just made sub-interfaces. Doesn't really matter. I see another question. Is can we practice DMVPN on GNS3? Yes, you can. And how does the hub know that if NHRP shortcut feature is turned on the spoke? The hub does not know about the NHRP shortcut on the spoke, but the spoke needs to have that, because when the hub sends him a redirect message saying, I'm going to install a route for you to accept the route, you need an NHRP shortcut. The hub is still going to send him a redirect without you having a shortcut, but you would not be able to install that in your table. That's the problem. That's why you need the shortcut for the spoke to accept the route, and the hub needs the redirect to hairpin that traffic or hairpin that request back down to spoke 1. So it's like, think of it like a hairpin that is actually going here and coming back as an NHRP request. That's why it looks like a hairpin. Right, so this is going to be my topology that I'm going to be building on. So let me in fact show you my routers. So I have the hub, which is here. If I do a show IP interface brief, I have my underlay IP address already pre-configured. This is my interesting traffic, my LAN segment, which matches my subnet here, 10.0.0.0/24. That's my LAN, represented as a loopback. If I look at my spoke 2, show IP interface brief, I have 133.2.2.2, which is my underlay, and this is my interesting traffic, which is 10.2.0.0/24. Again, as per the diagram, spoke 2. And then I have spoke 1, which is show IP interface brief. As you can see, I have my underlay IP address, which is 167.1.1.1. and 10.1.0.0 as my interesting traffic, which is going to be my LAN using a loopback. So I've already configured the basic underlay as such. So I have my LAN already configured. I have my underlay already configured. Do I have reachability? So because before I start DMVPN, we must have an underlay kind of reachability. Let's check. Can I reach the hub? 187.0.0.254. I can reach the hub. Can I reach the LAN segment behind? Maybe not. But I can reach 187.0.0.254, which is the hub's IP address. Can I reach the remote branch office? 167.1.1.1? Yes, I can. So I do have underlay reachability. If I look at from the hub side also, ping 133.2.2.2, which is POC 2, I can reach him, and 167.1.1.1, I can reach him too. So I do have my complete underlay reachability at this point of time. So let's in fact build DMVPN now. I'm going to do DMVPN Phase I first. Okay, I'm going to start off with the hub side. I will configure the hub side completely. I'm not going to use IPSec at this point of time. There's going to be no IPSec, just a GRE. So because I'm not doing IPSec, if there was an ASA or maybe a firewall in the middle, I would need to permit GRE because the ASA would see the GRE. But if I had IPSec, then ASA would need to permit UDP 500 and ESP packets. And if there, let's say there was NAT happening, then I would need to permit 4500, which is UDP 4500. So I'm going to start off with configuring the hub, and I'll explain each step that I do. So let's in fact build the tunnel first. So interface tunnel 0, as per my diagram, we need an IP address on the outside or on the tunnel, which is 172.16.1.254. That's my overlay IP address. So IP address 172.16.1.254, 255.255.255.0. Now, obviously, my tunnel needs to have, it can't just communicate with the remote people in the air. There has to be an underlay, right? It has to go physically through an underlay infrastructure. So I'm going to define my tunnel source. So tunnel source is going to be gig 1.1, which is my underlay interface. Now, usually without DMVPN, if it's just a normal GRE is point to point, I must define a tunnel destination. I must define that. But in DMVPN, there is no tunnel destination. You learn the destinations dynamically from client registration. So there is no tunnel destination. I'm just going to change this mode to tunnel mode to GRE multipoint. My tunnel comes up now. A few more things that I would normally do. I mean, it's not mandatory. It's not necessary that you have to do that. But I would normally do that, which is readjusting my MTU. Obviously, because there's an overhead of GRE and then it's going to be an overhead of IPSec. So I would normally adjust this. And I would also adjust my TCP adjust to 40 bytes lower than my MTU, which is 1360, to incorporate my 20 bytes for my IP header and 20 bytes for my TCP header. So that's why I would normally do this. It's not needed from a lab environment perspective. But from perspective of a production, yes, you would normally want to do that because otherwise you would have fragmentation issues. So I just have the habit of doing that always. So all I've done right now is I gave an IP address, I defined the tunnel source, there's no tunnel destination, changed my mode to GRE multipoint, and readjusted the MTU and the TCP adjust to incorporate my IP header and my TCP header, which is 20 bytes each. Next, I'm going to activate my NHRP. So IP NHRP network ID. Let's just use anything. Does this need to be same between hub and spoke? It does not need to be same. It could be different. It kind of makes relevance to identify the tunnel once you have, let's say, a dual hub or a dual cloud. It kind of makes relevance there when you have two tunnels for two different clouds. Let's say if you had two separate ISPs, then it makes sense to kind of keep it same. But otherwise, it doesn't really matter. I'm just going to use any number, any arbitrary number, 1 to 3. And all my NHRP requests, I need them to be authenticated just from a perspective of security. And let's change that to IP Let's do that to IP NHRP. Authentication, let's just use the password of Cisco. So all my NHRP request is going to be authenticated using this password, which is obviously something that you should not use as Cisco as a password. And I'm going to also add, let's say, a tunnel key. Again, tunnel key is optional. NHRP authentication, optional. I don't need that. It just gives you additional layer of security. Like even if I do tunnel key, it just gives you an additional layer of security, even though it's weak. It's a weak security, but it still allows, basically, it still prevents improper configuration or injection of packets from a foreign source. So you could still give that. Let's just use any other number, let's say 321. Let me show you my config again. Show run interface tunnel 0. So this is mandatory. All the spokes and all the branch offices, they need to be in the same broadcast domain. This comes automatically. This was optional. This is optional. You have to define this. This is mandatory. Optional. You have to define these two things. This is optional. The next thing I'm going to do is enable the hub to dynamically learn information about the clients, because the clients will come and register with the hub. There is no tunnel destination defined, right? We didn't define any tunnel destination. So how does the hub know which destination he should go to? How does he know that? Because the clients will come and register to the hub. So I must allow him to be able to accept dynamic registrations for the client. That's done with IP NHRP, map, multicast, and then I have the word dynamic, which says dynamically learn destination from client registrations on the hub. So that's going to be dynamic on the hub. What else should I do? I must disable split horizon because I am going to be using EIGRP, which has a split horizon issue, right? Routes learned on one interface cannot be given back out the same interface. So I need to disable split horizon. Let's do that. No IP split horizon, EIGRP, let's say 123. Any ES number, I'm just using an arbitrary number. And so let me again show you what all we've configured. I don't think I need anything else. I'm not doing IPSec at this point of time. And I'm configuring DMVPN Phase I. So I have the IP, MTU, split horizon is disabled, authentication is enabled, and he will accept dynamic registrations, and network ID is 123, TCP adjust has been configured, tunnel source has been defined with the correct underlay interface, and tunnel mode is GRE multipoint, and tunnel key is 321. Last step is going to be to activate my overlay routing protocol. That's going to be done with router EIGRP 123, and let's activate EIGRP on my overlay interface because the hub and the spoke will establish an EIGRP adjacency, so they must have EIGRP running. So 172.16.0.0. And also let's advertise my interesting traffic or my LAN segment that I want to advertise to my peer. So 10.0.0.0. I'm not being very specific. I'm just giving a /8. It doesn't really matter. But you must be careful about one thing. The most common mistake that I see is that in your overlay routing protocol, people advertise their underlay. Never ever advertise your underlay interface. Your gig 1.1 should never have EIGRP enabled because you would go into a recursive routing loop. Okay? So my hub is kind of ready with all the configuration. If I see right now, this is what my config looks like. Show run interface tunnel 0 and show run section router EIGRP. That's my whole config at this point of time. No IPSec at right now. Let's in fact build the spoke side also. The spoke side is going to be pretty much the same with one change only. Just one change. All right. So let's go to the spoke side. Let's start with router 1, which is spoke 1. And let's build our tunnel. IP address 172.16.1.1, which is as per our diagram. They must be in the same broadcast domain for them to be able to establish EIGRP adjacency. 255.255.255.0. Tunnel source is going to be gig 1.1. Tunnel mode is going to be GRE multipoint. I don't need to be giving GRE multipoint for DMVPN 1 at least, but since I know that I'm going to be moving from DMVPN 1 to DMVPN 2, you could still keep it as multipoint. And then I'm going to give my IP MTU. MTU should be same again if you're using OSPF, it must be same. Or you'll have to just say MTU ignore on OSPF. So IP MTU 1400, IP TCP adjust 1360, and network ID was 123. Then tunnel key, because I defined tunnel key on that side, I must define it here also, which was 321. So most of the commands are pretty much the same. If you see all of this, whatever I did right now, everything remains the same. I gave the IP, I've defined the MTU, except for this. The hub has how many neighbors? 2 neighbors. So he needs to disable the split horizon, right? Because he has 2 spokes. But the spoke, if you remember, I told you that spoke only establishes control plane with the hub. He only has 1 neighbor. So I don't need to disable on the spoke side. I have to give this because I have enabled on the hub side. So I would have to give that. Let's give that IP NHRP authentication as Cisco. So now most of my commands are pretty much the same. The only difference comes in is here. On the hub side, I gave the NHRP mapping as dynamic. Dynamically learn the registration. Dynamically learn the private and the public IP address from client registrations. At this point of time, can my hub, does he know about you? Nothing he knows about you at this point of time. Why? Because the client hasn't registered with you yet. I'm going to go now to my client and add the command. The only different command is IP NHRP NHS, who is your DNS server or your NHS server. It's the hub. It's the overlay IP address. So 172.16.1.254, which is the hub's overlay IP address, as you can see here. And then the NBMA address, which is your underlay IP address, is 187.0.0.254. And then run multicast, which means my neighborship is going to establish, my control plane neighborship is going to be running with the hub. The minute I give this, registration process starts. So I'm going to show you that. I'm just going to skip this right now. Let me do an unall, or in fact, maybe I think debug is already on. So I'll show you that. But the minute I gave that one command, look what happened in my local database. Show IP NHRP. I have a static mapping. So I statically defined, as you can see in this diagram, I have to statically define who the hub is, right? Where should I go and register? The minute I gave that command, it creates that static entry in my local database, which says the hub's private IP address is this, his NBMA address is this, and it's static registration or static entry in my local NHRP mapping. If I look at the hub now, look at the difference here. Let me show you the NHRP request. So sending an NHRP registration request to the hub. What does it contain? So sources is going over my tunnel. Source is my overlay IP. Destination is the overlay IP of the hub. And it contains my NBMA also, which is the spoke one's NBMA address. Hub received the resolution request. And then he sends him a registration reply. And now if I look at my hub, show IP NHRP, he has dynamically learned about the client. That this is the client's private IP address or the overlay IP address, and this is the hub, the spoke's underlay IP address or the public IP address. He's dynamically learned that. What's left on the spoke side? Just one thing now. Routing protocol. Overlay routing protocol. So router EIGRP 123, network my interesting traffic 10.100, or in fact I can just say 10.0.0.0, network 172.16.0.0. Now you should see that I should establish an EIGRP adjacency with the hub. Even the hub has established an EIGRP adjacency with the spoke. Show IP EIGRP neighbors. I have one neighbor at this point of time. I should have learned his LAN information, which is 10.1.0.0. And if I look at this spoke, show IP EIGRP neighbors, I have one neighbor, which is the hub, through my tunnel, and I have learned the hub's LAN segment, which is 10.0.0. I've learned that. Let's also build the second spoke. What do I need there? Most of my config remains the same. So interface tunnel 0, except for the IP address 172.16.1.2, 255.255.255.0. Tunnel source is going to be gig 1.1. Tunnel mode GRE multipoint. I don't need it to be multipoint for DMVPN 1, but I'm going to just give it as multipoint right now, just because I'm going to change it later on to DMVPN 2. Then tunnel key was 3 to 1. IP NHRP, network ID 1 to 3. And IP NHRP authentication is going to be Cisco. So if you see, most of my commands exactly the same from the spoke side. Exactly the same. I'm going to give my MTU and TCP adjust on here. So 1400 IP TCP adjust 1360. So it kind of looks the same now. I have the tunnel key, the mode, the source, the adjust, NHRP authentications, and IP address, which looks exactly the same as the spoke side, except for one command which I still have to give. It's going to be exactly the same on the other spoke side also. The minute I give this command, the spoke goes and registers with the hub, which you would be able to see now. Let's do a show debug. If I think my debug is on. It is on, so the minute I give this command, it should go and register with the hub. So sending a registration request from me to the hub, which contains my NBMA address, and received a reply, which you can see here, which means now the hub installs that in his NHRP mapping, which he has learned dynamically. Okay? He has learned that dynamically. So hub has learned about both the spokes dynamically, the private IP address and the public IP address. He's learned that dynamically. And if I look at the spoke side, let's look at the spoke now. I'm going to show you his NHRP mapping. Show IP NHRP. I have only one entry on spoke 1 and only one entry on spoke 2, which is a static mapping to the hub. Static mapping. Okay? And let's look at the routing table of spoke 1. Show IP route EIGRP. I have one route right now, which is 10.0.0.0, and I should be receiving the branch office route also once I enable EIGRP on spoke 2 also. So router EIGRP 1 to 3, network 10.0.0.0, and network 172.16.0.0. So I should now establish an EIGRP adjacency with the hub. Look at my control plane now. Irrespective of your whether it's DMVPN 1, 2, or 3, it doesn't really matter. If I do a show IP EIGRP neighbor, I have only one neighbor, the hub. If I look at spoke 1, show IP EIGRP neighbor, I have just one neighbor, the hub. The hub has two neighbors. That's why he needs to disable the split horizon. He has two neighbors. So there's no control plane neighborship between spoke 1 and spoke 2. Spoke 1 and spoke 2 only established with the hub. So I see a question that in what cases would you use loopback to create the DMVPN configuration? Let's say if you had like redundant paths on your underlay, and your loopback was also advertised in your underlay, it was reachable, then yes, you could use the loopback as the source of your underlay, so that irrespective of whichever path you go through, whether you go through ISP1, ISP2, doesn't really matter, it's your NHR DMVPN would not go down. Okay, so now that I have my DMVPN set up, let's look at how my traffic is flowing. I'm going to go to my spoke 1, and make sure my debug is on for NHRP. Go to spoke 2, make sure my debug is on for NHRP, and on hub, let's do a show debug, make sure my debug is on. And I'm going to do a ping from spoke 1 to spoke 2. All right, let's see what happens at the back end. Show IP route, EIGRP. Do I have routes to the branch office? Yes. Do I have routes? Yes. What's the next hop? My next hop is the hub, right? My next hop is the hub. Who is this hub? Who is 172.16.1.254? The first thing I'm going to check is my local NHRP mapping before questioning the DNS. Do I know who 172.16.1.254 is? Yes, he's 187.0.254. Let's do a ping to 10.2.0.2, sourcing from my loopback. Okay, so my LAN is trying to access the branch office's LAN. The ping worked. The ping worked. Let's look at my NHRP mapping. Do I have any entry? No. Did he send an NHRP request? No. So in DMVPN 1, he's not sending any request. The only reason being because his next hop is the hub. He already knows who the hub is. If I know who the hub is, why do I need to ask any DNS or NHS server that who is this person? I already know that. It's in my local database. So absolutely no NHRP request going to the hub at all. How is my traffic flowing? Trace route to 10.2.0.2, sourcing from loopback 0. How is my traffic flowing? It should go from the hub. All traffic would transit the hub. Always. That's DMVPN 1. All traffic going from the hub, no matter what. Control plane is always hub. But data plane goes through the hub. The only reason it goes to the hub is because of your next hop. Because your next hop is the hub. Do I know that next hop? Yes. Since I know it, I don't need to ask the NHS server, which is the hub. I don't need to ask him who is the spoke because my next hop is the hub. And I know that entry. I already know that statically. I have that with me. So that's why there's no NHRP request going in. Now this is DMVPN Phase I. So do we see an advantage over normal like site to site? Yeah, I don't need to build thousands of tunnels, but traffic goes through the hub always. It's kind of a disadvantage from a perspective of that now you would have a lot of problems of latency and jitter on the hub side because now everything is coming towards the hub. That's the problem with DMVPN 1. Let's move to DMVPN 2 and look at how the NHRP request or the resolution request comes in now. So my debug is still on. I'm going to go to my hub and tell the hub that you're not going to change the next hop. Keep the next hop unchanged. So always keep your next hop unchanged. That's done with tunnel 0. So interface tunnel 0. And let's do a no IP next hop self EIGRP 1 to 3. This is on by default in EIGRP, which means EIGRP by default changes the next hop to himself. That's why EIGRP by default natively is DMVPN 1. But if you do want that, if you want DMVPN 2, you can change that to be DMVPN 2 by disabling the next hop changing. So the hub would not modify the next hop. He would keep it unchanged. I see a question in DMVPN Phase I. Can the hub summarize? Of course he can summarize because it's DMVPN 1. You can summarize in DMVPN 1. You can summarize in DMVPN 3. You cannot summarize in DMVPN 2. So I see another question that as for OSPF, we will change the network type. Yes. So OSPF, it depends. There's no such command as no IP next hop self in OSPF. In OSPF, it depends on your network type. If you're going to use point to multi-point, then by default is DMVPN 1 because the hub puts himself as the next hop. If it's point to multi-point, it won't be DMVPN 2. So in that case, you would have to move to DMVPN 3 to make it spoke to spoke. But if I use network type as broadcast in DMVPN, in OSPF, then by default, the hub does not modify the next hop. which means by default OSPF in broadcast network type would be DMVPN 2, because the next hop is not modified in broadcast network type. So there depends on the network type rather than you giving a command in EIGRP. So the minute I do this, see the change that happens on the spoke side. Let's do a show IP route EIGRP. This time I have the route of the spoke, but look at my next hop. What's my next hop? My next hop is the remote branch office, which is spoke 2's overlay IP address. Now, if I do a show IP ceph, let's do a show IP ceph for 10.2.0.0. That's my entry. It says go to the next hop, which is the branch office, and let's give the word internal. You'll probably see it as incomplete. Why is that? Because right now spoke 1 does not know how do I get there. How do I get to 172.16.1.2? I don't know that. Since I do not know that, what is he going to do? So when the traffic has to flow from spoke 1 to spoke 2, he does a routing lookup. Do I have routes to that destination? Yes. What's my next hop? 172.16.1.2. Is that next hop reachable? I don't know the underlay IP address. Where should I send the request? Right? I don't know who he is. What's the underlay IP address? I don't know that. If I look at my NHRP mapping, my local database does not have any entry for 172.16.1.2. It's not there. So what does he do? Who is my NHS server? The hub. Hub is my NHS server, right? So now he's going to generate a request, which this time it's going to be an NHRP resolution request. Earlier, it was just a registration request. Earlier when he was registering. In DMVPN Phase I, there was no request sent to hub because the next hop was the hub. But in DMVPN 2, the next hop is the spoke. So he has to send a resolution request to the DNS server or your NHS server. So think about the NHS like a DNS. It's not actually a DNS, so don't get confused about that. But just like an example, so he sends a request to the hub this time. So now if I do a ping to 10.2.0.2, sourcing from my loopback. Let's see what happens. Do I know that destination? No. So now he sending an NHRP resolution request. What does he send in that? He sends his NBMA address, sourcing from him to destination 172.16.1.2. But where did he send it? He's sending it to the hub. If I look at the hub now, he received a resolution request. From who? From the spoke. Does he reply? No. He forwards that resolution request to the other branch office, which you can see here. He's forwarding to spoke 2 that NBMA address 167.1.1.1 and whose public IP is 172.16.1.1 wants to communicate with you. Spoke 2 received a resolution request and now he sends a reply to who? Spoke 1 directly, because he already knows spoke 1's NBMA address. So now if I look at spoke 1, received a resolution reply, and look at the reply from where it came. It came from 133.2.2.2, which is the underlay of spoke 2. So that's how my process is happening. My NHRP request comes here, this guy forwards it here, and this guy replies to him. That's my NHRP request. How's my traffic flowing? Originally, my traffic went through hub. The first data traffic must have gone through hub. But now if I do a trace route to 10.2.0.2, sourcing from my loopback, see how my traffic flows. It does not go to the hub anymore, which basically means now I have no latency and jitter issues, and I don't need more or enough bandwidth on the hub side because traffic is not going to the hub anymore. It's going spoke to spoke direct, as you can see here. Okay, so we can see here that we have 172.16.1.2 and it's directly transiting straight to the spoke 2. It's not transiting the hub anymore. I see a question that can you please show the packet capture for NHRP request? I mean, I don't have a Wireshark attached right now, but I do have a PDF of the Wireshark of the NHRP request, which I can probably share with you. You can just send me an email and I can share that with you. But we could just look at the debug. It kind of shows here from who the source is coming in, from where the destination is coming, which you can see here. It actually shows you here that the request was basically sent to the hub, and the reply came from the spoke. And same thing you can see here. He received the resolution request from the spoke 1, and he forwarded that to spoke 2. That's what you see here. So how's my traffic flowing? Direct spoke-to-spoke communication. But what was the problem in DMVPN 2? If you remember, the problem was that I cannot do summarization. So let's go to the hub and do summarization this time. So I'm going to go back to my tunnel and say IP summary address EIGRP 123 10.0.0.0 So I'm summarizing all the routes now. All my 10 subnet, which is my LAN segment. All right. So if I look at the spoke now, show IP route EIGRP. Do I have the branch offices network? No. I don't have any specific routes anymore. I only have one route, which is the /8 summarized route coming from the hub. What's my next hop? The hub. So now if I do a trace route to 10.2.0.2, sourcing from my loopback, will I send an NHRP request? No, because my next hop is the hub. And how will my traffic flow? Always through the hub. Which means even though I had disabled the next hop on the hub, because I've done summarization, now my traffic always flows through the hub. No matter what, it will always flow through the hub. Because I cannot summarize in DMVPN 2. That's where DMVPN 3 comes in. Now look at how DMVPN 3 works. When I keep my debugs on, we're going to look at the NHRP request. The NHRP request is not going to be sent by spoke 1. He will not send anything because his next hop is the hub. But the hub, without the spoke 1 asking for an NHRP resolution, the hub will send him a redirect, which means a hairpin is happening. He's going to send him an NHRP redirect message. And now the spoke will generate an NHRP resolution request to the actual destination that he's trying to access. Let's see that. So this kind of a NHRP redirect message is actually called as traffic indication. That's just a traffic indication to the spoke side telling him that you're using an unoptimized path for routing. There's a better path available. Use that. So I'm going to install a route for you. And so obviously you must have NHRP shortcut on your side. So right now we can see that everything is going through the hub. I mean, so again, I see a question, could you use a leak map with summary address to solve the summary and spoke-to-spoke traffic and keep it phase 2? Yes, of course you can do that. But then if you're going to leak some routes, then what's the point of doing summarization? Because it just beats the purpose, right? Because think from a production perspective. Are you going to be doing leak maps or something? Normally, the hub is just going to send a default route, just one route, default route to the spoke side. You're just going to send him one default route. So I mean, you could do a leak map, but think about if I had thousands of routes coming from the spoke, then it just beats the purpose of doing leak map then. Yep. All right, so let's try this. I'm going to go to my spoke and give the command interface tunnel 0 and say IP NHRP shortcut. And on spoke 2, the same thing. IP NHRP shortcut. And on the hub side, I'm going to go and say interface tunnel 0 IP NHRP redirect on the hub side. Okay. Let's look at the routing table first now. Show IP route EIGRP. Do I have specific routes? No, I only have one summarized route, which points to the hub. Will I send an NHRP request? No, because I know that hub. So I will not send an NHRP request asking for the spoke, correct? In the earlier case, if you see here, when we did DMVPN 2, I did send a request, sending a registration request for what? That who is this person? 172.16.1.2. I was sending an NHRP request earlier. Now, I'm not going to send one. But still, without me sending anything, the hub is going to do a hairpin and send an NHRP traffic indication message, which is a redirect, saying that there's a better path available. Send me an NHRP request now for the actual destination you're trying to access. And that NHRP request, the hub will forward to R2 or the spoke 2, and spoke 2 will respond to spoke 1. Okay, let's see that. I'm going to do a trace route to 10.2.0.2, sourcing from the loopback. My first packet should go from the hub, but I will not send an NHRP request, resolution request. Let's check. Can you see this? My first message itself. I never sent a request. My first message itself was received something. Normally it's I send something, then I receive something. But this time it was received straight. So if I look back up here, I received a traffic indication message which contains what? Redirect. I received that from the hub. So he did a hairpin and sent you a message saying there's a better path available. Send me a resolution request for the actual destination 10. What about your destination? 10.2, right? So now R1 or spoke 1 sends a resolution request from his overlay to the actual destination 10.2.0.2. What does the hub do? So the hub received the resolution request for that 10.2.0.2 and he forwards the resolution request to who? To R2. If I look at R2, he should receive the resolution request which contains the NBMA of R1. And now he sends a reply. And if I look at R1, R1 receives a reply from who? NBMA spoke 2. So you see how it's triggering. The process is pretty much the same like DMVPN 2. There's only one change. Earlier in DMVPN 2, you were sending an NHRP request, the hub was forwarding to R2, and then R2 was sending the reply to R1. Okay? But here in DMVPN 3, the spoke 1 does not send a request, but he still receives a traffic indication message back. And now the spoke 1 sends an NHRP request to the actual destination. The hub forwards that request to R2 and R2 responds back to me. So it's pretty much the same with a slight change. So it's the NHRP redirect which basically triggers. The minute the hub receives a packet destined for the remote spoke, he does the hairpinning and he starts the NHRP redirect message, sending it back to the spoke saying, hey, there's a better path available. Here is the route. Now you need to be shortcut enabled to accept that. Look at the difference. You remember what was my next hop earlier? If I look at my routing table, nothing has changed in my routing table. But if I look at my CEF table for destination 10.2.0.2, if I look at this, look at my next hop. It's now pointing to the spoke, not the hub anymore. So this, for you to be able to receive that, you must be shortcut enabled. You don't need shortcut on the hub. You only need redirect on the hub because the hub sends the redirect or the traffic indication message back to the spoke. But the spoke, for him to receive or accept that, right? What is the hub telling him? You are using an unoptimized path. Here is a better path. For you to accept it, you must be shortcut enabled. That's called traffic indication, which is a redirect message. You must be shortcut enabled to accept that. Otherwise, the hub is going to send you, but you will never accept it. So your CEF table would never be modified to basically use the spoke 2, rather than he would always be going to spoke 1 or the hub always. So yes, you do need to have the shortcut command on the spoke, but not on the hub. Hub only requires the redirect. So this was my DMVPN Phase III. So even though I have done summarization, spoke-to-spoke communication is direct. 10.0.2.2 source loopback. You will see that my traffic flows always from spoke-to-spoke now, because the tunnel has been dynamically built between spoke 1 and spoke 2. That's how my communication is happening. Now that we have DMVPN built completely, we've seen DMVPN 1, we've seen DMVPN 2, we've seen DMVPN 3. Let's add another layer of security to our DMVPN, because right now, obviously my data is not protected. It's just a GRE tunnel, right? My data is not protected at this point of time. So obviously we need to protect or secure our data, and that's going to happen through IPSec. I see a question. Upon receiving a redirect message from the hub, the spoke installs a new NHRP route entry in the routing table. Not in the routing table, but in the NHRP map table. So if I look at my routing table, there's nothing in my routing table. It's still the same. If I do a show IP route, yes, you may see this. Okay, so this is indicating that I'm going to give you a new route. So for you to accept this, you require the shortcut command. Who is giving him this? The hub. The hub sends a redirect message, and he sends you back a better route, a route for the routing table, saying, here's a better route. Use this. But for you to accept that, you should be shortcut enabled. Otherwise, you would just discard that information. Okay? You can also see this route in your NHRP. So if I do a show IP NHRP, you'll see this route here for the actual destination that you're trying to access, which says a rib override has happened. So it's basically added that route in the rib, which you saw when I did a show IP route. Don't look at the EIGRP, because in EIGRP you will not see. It's not an EIGRP route. It's an NHRP route. So you'll see that as, if you do a show IP route, you'll see it as H, which kind of shows you that it is an NHRP route. Okay, so let me, in fact, before I summarize this to moving towards IPSec, some of you guys asked that, can you show us the tunnel configuration? Yes, let me show you my tunnel configuration. I'm just going to take this as one. Show run section router EIGRP and interface tunnel. There you go. That's my whole config for the spoke side. I see another question. In some codes, you have the next hop override flag. Yes, that depends on the iOS code. So if you're above 15.2, then yes, you would see the flag. It's like a percentage sign that you would see in the routing table. So this is my spoke side configuration. Let me show you the hub side also. Show run section router EIGRP and interface tunnel 0. This is my hub side. All right, so let's in fact now add another layer of security to our DMVPN, and that's going to be done through IPSec. Now I could do IPv1, I could do IPv2. I mean, obviously DMVPN supports both of them. So let's in fact, just for the sake of implementing it, we can just do maybe IPv1, or we could do IPv2. In fact, let's in fact do IPv2. All right, so what I'm going to do is create an IPv2 proposal. Obviously, they don't have enough time for me to actually explain the IKE process, I'll probably create another webinar for just IKE, because it could probably take a whole day on just IKE processes and how the debugs look like for IKE v1 and IKE v2. But let me just implement another layer of IKE. So I'm going to create an IKE v2 proposal. And this proposal is going to contain my encryption algorithms, my Diffie element. It's going to contain my integrity. So let's name this as, let's say, version 2 proposal. Let's have encryption as AES 256. Let's also add 192. Maybe we can add 128. Integrity is going to be SHA-512 and maybe SHA-256. Diffie element group could be 15, 14. So the key advantage of using IKE v2 is it's much faster because it has one proposal which has list of attributes inside that, rather than using IKE v1 where you have to create multiple policies for different attributes. So if I had like 10 different policies that I need, or 10 different attributes I need, I have to create 10 policies. And it sends one policy at one time. That's why IKE v1 is slower. And IKE v2 is obviously much faster from messages perspective. At the same time, it has DDoS prevention built in for VPN. It has dead peer detection. It supports better encryption parameters. It supports asymmetric authentication, asymmetric passwords. So a lot of features available for IKE v2. Now, what implementation I'm doing of DMVPN right now, it's not a Flex VPN config. So you don't get confused about that. Flex VPN is completely different. That's a unified config, which supports everything, whether it's a site-to-site, a remote access, or a hub and site. So that's a unified config. So I'm not doing a Flex VPN config. I'm just doing a basic IKE v2 support on my DMVPN. So I have my proposal created. This proposal is going to be called in an IKE v2 policy. Let's name this v2 policy, which will contain my proposal, v2 proposal. So if you see right now, all I have done is done crypto IKE v2. I made a proposal which contains list of attributes, and then I have a policy which contains the proposal. Next thing I'm going to do is create my keyring. If I do want it to be, let's say, asymmetric, I could create a keyring which could make it asymmetric. The best part about IKE v2 is that I don't need to make it authentication as pre-share. I could even do certificate-based, and I could match traffic based on domain. Let's say if anybody belongs to the domain INE.com, then yes, you can connect to me. You could do a VPN. So I could match traffic based on domain name or an email or an FQDN rather than just matching on an address, which IKE v1 only matches on address. But IKE v2 can match on email also, can match on domain also, or an FQDN also. Obviously right now, again, due to limitations of time, I'm going to keep it simple and keep it as address right now. So let's make a keyring. Technically, I don't need a keyring if I'm going to keep the same password. If I'm going to keep it symmetric, I don't need to have a keyring defined. I could just go and just create an IKE v2 profile directly. But let's say if you had to create different passwords, then yes, you could go and create keyrings with multiple peers. I'm just going to go and say crypto IKE v2 profile. Create a profile. Let's name this v2 profile. And here I'm going to define my authentication local. It's going to be through pre-share. Because I didn't make the keyring, I have to define the key here. So let's keep the key as Cisco. Authentication remote pre-share. Password is going to be Cisco. So just keeping it simple. Match identity of the remote is going to be based on the address. Just to make it scalable, I'm going to keep it as 0000. Which you should never do from a production perspective. It's just less secure. And that's it. That's all I have to do in my IKE v2 profile. So all I did was create an authentication profile, an IKE v2 profile, which contains an authentication local pre-share key, a remote pre-share key, and I match the identity of my spoke offices using address 0.0.0.0. But if I had to give it specific, this should be your underlay IP address, okay, which is your actual IP address, your public IP address. Next, I'm going to create my transform set. How should my data be protected? Using my transform set. So crypto IPSec transform set. Let's name this as V2TS. Let's use ESP AES 256 and ESP SHA-512. Lastly, I'm going to go and create an IPSec profile. Let's name this V2 IPSec and call my transform set in that. So set transform set as V2TS and call my IKE V2 profile inside this. I'll show you my whole config, what I've done before I apply this. So show run section crypto IK V2 and crypto IPSec. This is my entire config, what I've done right now. So I have a proposal, which goes inside a policy. I have a profile, which contains the authentication mechanism. And how do I identify my peer? I have my transform set, and then I call my transform set inside a container, which is an IPSec profile, which contains the transform set and my profile. All right. Once I have this, now this should be exactly the same on all of the branch offices. Just to keep it simple, I'm just keeping it the same. My passwords are same. My remote address is 0.0.0.0. Just to keep it simple. Again, because of time restraint that we have, just to keep it simple. But from a production perspective, I would never do that. Let's go to the spoke side and apply the exact same config on the spoke side also. Exactly the same. And on spoke 1, 2, let's add the same config. Exactly the same. Now, once I've done that, I'm going to now go and apply this IPSec profile that I created on my tunnel. That how should my tunnel be protected? I need my tunnel to be protected using IPSec. So this time, your traffic your data is going to be protected using, so you'll have a GRE encapsulation. On top of that, you have IPSec. So that's why we need to adjust the MTU to avoid fragmentation issues. So if you had a firewall in the middle, what will the firewall see? Not GRE, he would see IPSec. So you need to explicitly permit in your firewall a UDP 500 and ESP. So I'm going to go back to my tunnel and say interface tunnel 0. Protect this tunnel, so tunnel protection using IPSec profile that I created, which was V2 IPSec, which was my IPSec profile name. The minute I do this, my neighborship with the spokes will go down. If you see, my neighborship just went down because the branch office is not configured for protecting the tunnel. So let's apply it here also. Tunnel protection, IPSec profile, V2 IPSec. He should register again. So sending a registration request again. And my neighborship just came back up. Same thing on spoke 2. Interface tunnel 0. Tunnel protection, IPSec profile, V2 IPSec. Again, he should re-register with my hub. And my data is now protected using IPSec. Let's do an unall on all of them. Unall. And this time, I will turn on a debug for crypto IKE V2. Before I do a ping between the spoke and spoke, let's do a show crypto IKE V2 SA. As you can see, I have a VPN tunnel built between spoke and hub. There's no spoke to spoke right now. If I look at the hub, show crypto IKE V2 SA, I have a VPN tunnel with both my spokes. Correct? Hub has a VPN tunnel with both of them, IPSec tunnel. Spoke has only with the hub right now. If I look at my NHRP mapping, I just have this. There's no entry about the remote spoke. I only have of the hub. All right? I'm going to do a debug crypto IKE v2. Same thing on the spoke. Debug crypto IKE v2. And on the hub, let's do a debug crypto IKE v2. Okay. And let's go to spoke 1. Does he have a VPN with remote spoke? No. Let's do a trace route to 110.2.0.2, sourcing from loopback 0. The NHRP process is exactly the same. That because it's DMVPN 3 right now, I don't send a request, hub sends me a redirect, then I send a request for a destination, which the hub forwards to destination, and destination spoke 2 responds back to me. And NHRP process is still the same. But look at my IKE v2 process now. What's going to happen? Where does the first packet go? It goes to the hub, right? I already have a VPN with him, which means my packet would be encapsulated as IPSec and going towards the hub. The hub forwards that towards the spoke. So my original traffic goes through the hub. But at the back end, once they know about each other through NHRP, what's going to happen? Now they know each other. They're going to start establishing IKE v2 requests between each other. And they would form a tunnel with each other. Let's see that. As you can see that I have some requests or IKE v2 process happening at the back end. Authentication pass, I could see it here. If I let this finish off, then I can show it to you. All right, so this should be nearly complete. Let's do an unall now. And unall here also. There was no debug here. Why? Because my VPN with the hub was already there. But between spokes, a VPN negotiation started. Let's do a show crypto IKE v2. I have a VPN now between spoke 1 and spoke 2 up and running. If I do a show crypto IPSec essay, so let's do a show crypto IPSec essay, you should see your IPSec tunnel up and my data is protected between them. So if I do a trace route now, my traffic should go directly spoke to spoke. It should not transit the hub. I'll also show you my debug output. I see a question. If I configure dual hub, single cloud, I configure 2 NHS entries. Yes, that is correct. You configure 2 NHS entries. The client will set up 2 EIGRP neighborship with both hubs. That is correct. So you will have, the client will never form with each other. The client will form with both the hubs, EIGRP adjacency. Okay, so now it's transiting directly the hub. I mean, it's transiting directly to the spoke. It's not going through the hub. Now let's look at the debug output. Let's go scroll back all the way up. Should be starting off from here. Here you go. So searching for the policy, found the policy v2 policy, which contains the proposals. It starts the negotiation for the v2 policy, whatever attributes are inside that. as you would be able to see what policy got accepted. So there's an exchange happening. And my authentication process started. NAT was not found. Peer was authenticated. And then finally, my IPSec should have started somewhere here. IPSec negotiation. Here you go. Your IPSec negotiation started. And then building packet for encryption. So you see the process was directly between spoke and spoke. Once they learn about NHRP, the IKE V2 will only start after that. So as soon as the spoke 2 receives a request from the hub, when the hub forwards that request to the spoke 2, when he replies back to you, before he can reply back to you, he must have your IPSec up and running. So he starts the IPSec first. If the IPSec does not work, or if it fails, then obviously your NHRP reply would not be heard by spoke 1. Because now your NHRP is also inside. Everything is inside. All right. So this was just basic implementation of our DMVPN. Going back to our slide. So with this, we have covered most of the things that we could do in these 2 hours. I hope this webinar was informative to you guys, and I would now ask, if you want to ask any questions, you can definitely ask questions at this point of time. Now, one thing that you must know is that in case if you do have questions, you can always email me. Let me write down my email. So you could send me an email on rohit@INE.com. At the same time, if you do want to know about what boot camps we are currently running, if you actually go to any of our website, we have a lot of information there. We have a blog site also. So most of my boot camps are listed there. So I have some route switch written boot camps in case if you want to look at the written one. We have some for the lab as well. There are some boot camps for security written as well as the lab. The locations would be here. You can just directly check them out. And all of these boot camps can also be attended online. So you don't have to be on site. You could do it online also. All right, so you can ask me any questions now. If you do have any questions,